We have today the ESTCP task 34. It was completed recently. The title is Comfort and Climate Box. Today the talk will be given by Peter Wagener, who is the task manager of the task. And yes, I'm very happy that he's giving a long idea about what happened in the talk. So please, Peter, the stage is yours.
Thank you very much, Stephanie.
Yes.
Welcome, ladies and gentlemen. I'll share my screen with you, and I will see if it works in presenter mode. Yes, thank you for the opportunity to show you the outcome of task 34. It was called Annex 34 when it started, but within the IEA, we call annexes now tasks. So if you see the word annex, think about the tasks. And today I give you an impression of the project, the idea behind it, and the results of it. And we have taken some time for today. So if I raise any questions, there will be a great opportunity at the end of the presentation to take your questions. First of all, I will show you the overview build-up of the annex. And this was a slide set I used for TCP also. So that's why Annex 55, but within energy storage, it was Annex 34. Then I will go in detail through the final report. I'm happy to share with you the lessons learned and also the unfinished business, or so-called unsolved issues of the CCB annex. And I can already disclose a little bit for you. There is a CCB2 and a CCB3 already in the making. So it really makes sense. Why an integrated solution? Well, it started with a discussion from, I think, summer 2018 within mission innovation and also in the TCP energy storage and the TCP heat pumps, that they combined project of heat pumps and energy storage would be very relevant and very interesting to conduct. One of the things which motivates me as a task manager is, let's say, that until now, the Artisanal heating installer buys a heat pump, and he buys all kind of loose components. And then at the end of the day, we all hope he has built it up together to a properly functioning for at least 15 years heat pump installation. And the service departments of the heat pump manufacturers know that's still not something which is, let's say, self-explanatory and logical to happen to a heat pump installation. And the idea behind the CCB idea, which, as I told you, was born in 2018, is to come up with at that time, a term invented, Comfort and Climate Box, one device which could provide heating and cooling and domestic hot water for a house. We are limited to the domestic sector, and we don't do, let's say, utility buildings in this project. And also important for the attendants to know is that we had a technology readiness level of 7 and higher. That means this annex was to a lesser degree on, let's say, fundamental research, materials, etc., than on, let's say, trying to combine. So this is not a hard technological annex, which in the past were much frequently conducted, but more an implementation type of annex to see if we could combine heat pumps and energy storage, including the control system, into one complete package. And again, TRL 7 and higher. In 2019, we saw during the early stages of this annex that there were criteria popping up, which were the design considerations for such a climate box. Until now, the industry has done his job for storage, has done his job for heat pumps, but never has done his job for, let's say, combined devices. And I also can disclose that it's now mid-2022, we already see some signs in the industry that these integrated solutions are a very, very promising development direction for the industry. So we came up with at that time, 9 criteria. Affordability, people should be able to buy it. Suitability, it should shoot into the houses. Dimension-wise, cost-wise, etc. And would also be compact enough. We need an integral design. It should be plug and play. I'll show you a nice picture of what I think is plug and play. Efficiency, of course, it should have a nice efficiency as a total package. Smart grid ready, because a CCB type of applications should be connected to smart grid developments, and controls play a very, very dominant role in that. And we should also look into the appreciation of the technology, that people consider this as well, the installer as the end user, as a suitable solution for the heating and cooling and domestic water demands. So the focus was to improving the integration between the heat pump and storage components. The CCB should not be a set of separate components that have been put together random-wise, but from a design point of view with a integral control strategy. And they should work together under this integrated control strategy, and that's very important. And normally, heat pumps are typically designed for the best energy efficiency. That's what the industry, heat pump industry, aims for. So high COP and the storage options there are designed for low thermal losses, depending on thermal storage. But if you look to those components from a system perspective, performance goals for a CCB should be extended beyond energy efficiency. And we have defined 4 archetypes for possible implementation strategies of comfort and climate boxes, and that are based on other criteria also than just energy efficiency, because you can have better 1 million heat pumps with a, let's say, SCOP of 4 than 1,000 heat pumps with a SCOP of 6. That's our motto. I think it's the same slide, sorry. So we drafted 4 archetypes for CCB implementations, 4 perspectives. Is the affordability, the flexibility. The affordability has to do with the compactness also, because compactor units are generally more affordable. Flexibility, it relates to, amongst others, to the grid, compactness and energy efficiency. And those 4 you will see throughout the rest of my presentation. And the focus with affordability is to keep the investment to the end user as low as possible. That can imply that we accept a somewhat lower energy efficiency and also modest capabilities, not let's say the optimal capabilities, for flexible operation strategies connected to the grid, for example. If we look into flexibility, we want a apparatus, we want the CCB as optimal integrated in smart grids. And therefore, you need a larger storage size than with the focus from affordability. And you also need very sophisticated controls. And depending on the chosen flexibility goals, the energy efficient may be second to, let's say, the flexibility for reaching the flexibility goals. So you see, in one hand, it's the money who is predominant. In the second one, we look into, let's say, the flexibility we have to offer to the grid. The third one is compactness, because generally in our houses in Europe, floor spacing is at a premium. So that means if you really use a big storage units, big boilers or big PCM storage containers, you run into trouble of getting those units installed in the houses. So compactness is one also. And compactness means also you accept a smaller storage and you also accept a lower energy efficiency. It's not always connected one-to-one, but generally you could say you accept somewhat lower energy efficiency because you have a smaller storage size. And last but not least, you say, okay, we have a fourth one, that's energy efficiency. We go flat out 100% for best performance under various use conditions, but generally it implies a larger size for the installation and higher investment. And then the efficiency aspect corresponds more closely to the traditional quality heat pump storage system. And the other three are not specifically targeted by research, product developments, etc., but they are, let's say, until now, a byproduct. And for policymakers, the output of this annex is aiming for, amongst others, policymakers as a very important target group. We also make a summary about policy recommendations, especially for them. The 4 archetypes can help to achieve different policy goals and different use cases, because policy makers, for example, can really aim for designing legislation to go for affordability. So a large group of inhabitants in the country can afford a efficient CCB type solution for their heating in their houses. The quality criteria I drafted are accompanied by quality in total by the quality criteria. And here you see the level of integration, market suitability, customer appreciation, plug and play, easy maintenance. They play also a very important role besides the other 4 as I have shown before. And we think you have to look at policy recommendations, market developments, but also research projects. Because we have a variety of countries. We had 11 countries. I tell you a little bit more later on, participating in this annex. And those markets differ strongly. They have different characteristics, different focus on technology. And it's important to see how we can make this quality criteria related to the CCP packages usable in the participating countries in this annex. And as Stephanie told you with the introduction, the Netherlands was chosen as the task leader, and the Dutch government took care of the funding for the cost of the task leader. The work packages were run by several people from the participants. Italy covered the work package 3 and 6, Università Politecnica de March by Alessia Attaccioni. Work package 7 was covered by Sweden by Karin Heklen-Stickler from RISE. Work package 2 by Turkey by Halim Paksoy from Cukurova University. And the UK took care of work package 4 and 5. And I want to thank the work package leaders for the work they've done, because it was really a sizable quantity of information we had to digest to get into the final report. The total final report, including all attachments, etc., is roughly 250 to 80 pages. So you can understand there was some work to be done by the work package leaders. And all I've shown you until now is, let's say, a kind of introduction to the Comfort and Climate box. Perhaps a good moment to ask the attendants if there are any questions about my presentation so far before I continue with the final report. Are there any questions? I hear no questions, so I think I will proceed. Then I'll show you the final report, which is, let's say, at the really final stage. We're now working on it to rework it in the standard format of the energy storage TCP. But let's say the final report will be available around summer or early after the summer holidays online on the website. We divided the final report at the end in 7 parts: an overview and summary, market status in participating countries, or charting the waters, like we say, because there we make visible how the countries differ in the 11 countries in the Annex differ from each other. But there's also the beauty in it, because there you can see how things work in other countries in different energy systems. Then we have an overview of field trial results. A part 4 will describe the technical boundary conditions in participating countries, including some statements about smart grid readiness. Part 5 will be the other research projects, 6 standards and testing standards, and part 7, last but not least, the roadmap, which is also an important part of the package. And like I've shown you already, work package and report leaders, I showed you already in the previous slide, and the report was built around these implementation strategies and quality criteria again. So I won't go through this 250 pages this afternoon, because it then will be very late for you all today, and I will be mild for you. I keep it to a smaller set, but within the, let's say, the various detailed reports who you can find online in due course of time, you will find the quality criteria back over and over again in the various reports. And then a spoiler alert regarding physical prototyping. In 2018, we were enlightened. We got a funding by the Ministry of Economic Affairs in the Netherlands as a task leader, which was really great. And there was also talk of doing physical prototyping within various countries. And this would be one of the TCP overarching annexes, so energy storage and heat pump technology. And then at the same time, we should also do for first time within an annex some physical prototyping. But then there came a bet from China, and what happened with COVID, I don't have to explain to you. The whole world went upside down, and our prototyping was jeopardized by the restrictions, unfortunately. At the end of it, we think with the report we make you available soon, we still give you a very, very valuable output, which can be still be very useful for policymakers, manufacturers, etc., etc. At the same time, we saw that the industry wasn't completely silent also. We saw the first CCP type solutions entering the market, which in our eyes is an indication that the market tends to go technology-wise already a little bit into that direction, which is on itself okay, but the speed where the industry is acting on, we could, I think, see some room for improvement. At the moment, we have throughout Europe, I think anywhere in the world, a very, very strong demand for heat pumps. And that might slow down a little bit, perhaps, the enthusiasm to go for new developments, because the manufacturers already sell enough heat pumps. On the other hand, we think the size CCB type of solution is so promising, also the industry will pick it up more. Report number 1, the summary and overview by the operating agent. Well, not too much honor for the guy who just runs the project, or the people who run the project. We made an overview and a summary, which is built up from report 2 until report 7. You get a one-page policy recommendation sheets, you get a summary, and you also get a ton of attachments where you can find per part of the project your detailed information. Report number 2, market status by Cukurova University from Turkey. And Helime Paksoy and Isaac Setin really did a very good job in describing, let's say, the market status in various countries. And this charting the waters is at the start of an annex, always an obvious mandatory thing, because that's what gives you the overview of the countries we're talking about. But especially in our annex, it was a very important one, because we had 2 technologies to connect, storage and heat pumps. And you see here the table of contents. This was thoroughly done by Halima and her colleagues about the heating markets in the country, but also the energy sources used. But also they made an assessment per country, and I must say this was finalized at fall 2021. So it's information from last year, and the world stays turning around. So it will change also in the course of time, but it gives you a brief overview what the status is in various countries along the way of this quality criteria we showed you earlier in this annex. And we should really recommend you to read report number 2 always before delving into the other ones, because it makes the understanding of the other reports more easy. Because what we here show is also developments in the markets in the various countries, and it gives you a good understanding why things develop in the various countries in which way. And I've asked myself, where do I put the sheet of plug and play? Well, I thought I put it here because it's also a little bit charting the waters. Until today, there is very too less plug and playness in heat pumps. When a heat pump is installed, it still needs an hour or 2, 3 to get it started up and configured. And I think nobody of you buys a laptop to spend another day after buying that laptop to configure your laptop, etc., etc. And the laptop is a much more complicated device than a heat pump. So where we really advocate for is a plug and play in heat pumps, which meets, let's say, this standard we see here from an antenna, from an internet router used anywhere in the world. This case comes from the Netherlands, but that's what we need if we talk about plug and plays. Then report number 3, field trials, which was done by Alessia Piccioni from Italy. What we collected here is the field trials which were already running in various countries with CCB type of applications, because we're not coming into comfort climate box type of solutions from a white sheet. There is already a lot going on. And you see from Canada, Austria, Turkey, the Netherlands, examples about field trials solutions. And we also have in the report more details about, let's say, designing technical solutions with details of the pumps and the circuits, etc. So you can find, if you're really looking for hardcore technology, it's in there also. But what you also have seen is that there is already development going on in various countries. And this is, for example, from the Netherlands, where we see we combine a heat pump and a storage solution in one casing, but they're all coming from separate brands. And we think this is not the really integrated solution. Here you have a cow, a dog, and a monkey in one cage. You try to have them talking to each other. And what we want is a cage full of monkeys, and then smart monkeys. But this is a very good start, because at least we're getting somewhere, and it's a good solution for also the installation sector to get used to pre-assembled total installations which serve the heating, cooling, and domestic water demand of the house. And this one is more another type of solution from a manufacturer from Scandinavia, and this has a source as an exhaust heat pump, but also air from outside. But what is nice to see is that a few years ago these solutions were not there, and are now slowly but surely also coming into the market. The idea from us as a task leader behind this whole CCB solution is that you can better pre-assemble a total unit on a production line in a controlled environment of a factory than, let's say, build up an installation of a bunch of loose components, as I have shown you in the opening of my presentation. And then technical boundary conditions in participating countries. This is what I earlier said. What we appreciate from the Annex as a typical value is that you can learn from the countries. In the countries, you can learn from each other and what happens there. And the boundary conditions per country differ. And it's not a big report. We will make an additional chapter in this one about smart grids. That was the recommendation of the EXCO to do so. That's one of the last things we have to do, and then it's ready. But at least we give you an idea about housing, stock energy use, flexibility management, storage optimization, and smart grids connection. And also, we try to give you a clue about flexibility with heat pumps and storage, because that's one of the important aims of a CCB type development, is that you get it connected to the smart grid and achieve flexibility to avoid grid congestion. And then we have a big report number 5, which was built up by Neil Hewitt from the Ulster University. And you can already see this is quite a big one. And this is a combination of projects with a heat pump and energy storage, and heat pump and a domestic hot water storage. And this is the other last thing we will change to this report scheme, is that we'll make it distinguishable for you which are the projects with heat pumps and energy storage, and which are the projects with the heat pump and domestic hot water storage. The latter is more a common heat pump application. The first one, the heat pump with energy storage, is more the real thing, aiming for the CCB type direction. And what you will see in this report type is a lot of projects. We again have been judged along affordability, compactness, flexibility, and efficiency. So you can rapidly have a look into a project and the details which are of interest to you. And please don't hesitate to contact people which are mentioned in the project. They will be eager to help you with some more additional information if requested. And then not unimportant is standards. We have standards for energy storage in at least Europe and the USA. We have standards for heat pumps in Europe and USA, but we don't have standards for heat pumps with energy storage in one combined device. So this was really, let's say, flying in the fog on the automatic pilot, but not knowing where we were going. And Alessia really put up some effort to make a good overview here. And at least we have an overview now about existing standards from heat pumps. We have an overview of the existing standards for storage. And also we have a little bit a guidance already, which was not there, to have at least an approach for, let's say, a standard for a CCB type of products. So heat pump, energy storage, with the domestic hot water facility under one control strategy. And since I'm the task leader and I'm not the guy who drafted these pictures, please don't examine me about the details of this one, because I will not be able to help you. The red line within this, if we were able to make a kind of experimental testing approach for, let's say, the CCB type of products. And since we didn't have anything for that, we at least have now a stage 1. And as I told you in the opening of my presentation, there are some discussions running about a CCB2. CCB2 will be for hot and humid climates, and CCB2 will be run by Oak Ridge Laboratories from the United States. And CCB3 might be a next stage development to go for real integration and more depth technology of, let's say, what we see here. So we try to proceed more on the testing side, on the standardization side, etc. And CCB3 would be, let's say, a logical successor of CCB1. And CCB1 is what you are looking at the moment. And what's important with comfort climate boxes is they can get connected to the smart grid in the future, because we see in almost any country the problems of the electrification of heating and cooling, and we need smart grids to a maximum extent. The smart grid readiness indicator, the smart grid readiness indicator, SRI, is a thing from the EU. There is an EU directive about that. And the domains the CCP works on in this SRI approach is heating, cooling, and domestic hot water. And what we can offer with the CCP is energy savings. We could, when we are so thoroughly connected, offer maintenance and fault prediction. So predictional maintenance we can do. We could enhance the comfort level in the houses, the convenience, information to occupants, and the grid flexibility and storage, which is number F, but could be number A also in the services, is available also if we take care of this smart grid readiness indicator. This part, smart grid readiness indicator, will go to the chapter or report of technical boundaries to make it more visible to the reader. This was one of the recommendations of the review by Energy Storage Exco. And the criteria for smart grid readiness are peak load level of the heat pump, capacity of the heat pump, storage size capacity, and of course, a very important discharge speed of the storage facility, levels of sophistication of the controls. That is it a dump one, which is once it is installed, it stays there, or is it updatable over the air, or even by artificial intelligence? We see that now coming up in the market, control systems which use artificial intelligence to make them self-learning and to optimize, let's say, the performance of the unit. Level of sophistication is important. And another thing is user behavior. And it's not always that's recognized that strongly, but user behavior is still a very important component in the use of heating devices. And then the roadmap number 7 was written by Karin Hägglund from RISE from Sweden, and without diminishing the other reports, but this roadmap is generally by policymakers recognized as an important one for them. And what you here see is that we make an overview of the main recommendations. And again, we use affordability, flexibility, compactness, and efficiency as the 4 criteria. And we have recommendations by stakeholder. We also describe standardizations organization which you can use. And we have quite a ton of appendixes about policies, energy markets, communication protocols, installation, suitability, etc., etc. And the main recommendations from this roadmap is that we think that heat pumps, which are now sold in really rapidly growing numbers, could even be accelerated more if they combine them with a storage solution in an integrated type solution like the CCB. What you also see that country by country, region, different strategies are recommended to be implemented because not 2 countries are the same. So you have to look into the country by country, how you want to conduct the introduction or speeding up the introduction of CCP type solutions. And the recommendations for each of these 4 implementation strategies are listed in report number 7. And I won't go through the report in detail. There will be a 1-page summary for policy recommendations separately in the report, which is always very appreciated by policymakers on governmental level. And then last but not least, the overview and summary. But that's a compilation of report number 2 until 7. Any questions so far?
Okay, if no one has a question, I might take the chance.
Mm-hmm.
Do you have also, it must be for each country in this case, but do you have also considered things like the payback time, for example? Let's say, how much could be the payback time shorter if you have this TCP solution instead of having each component extra? Because this makes always extra maintenance and installation and so on. Or is this too specific?
This is too specific because you need information about the investment amount,
yes,
which vary per country. For another project, we do some investigations about cost of installation in Germany, Netherlands, and UK, just to get some comparison. You see huge differences. Second thing, you see differences on level of investment for the equipment. It's just the materials.
Yeah.
And not important are the energy prices per country. And the energy prices per country are varying strongly because they are a fiscal influenced phenomena. So countries tax energy quite strongly, and that varies already country by country. The Netherlands has a relatively low energy cost with a high energy tax. And now, since somebody in the Kremlin went completely berserk, we see energy prices through the roof, and payback times for heat pumps are now not longer an issue.
Yes.
Assume that the world will stabilize a little bit more somewhere in the future, not in 6 weeks, but hopefully in 6 months or 18 months, we will get back to a somewhat more normal level. I would say, generally spoken, a product which comes from a factory, pre-assembled, I think has less risk of failure in assembling and installing, is installed more quickly with less labor hours, should at the end of it at least ask for a lower investment. What that means for the payback time, I don't know, Stephanie, but that should be better also. Yeah.
I imagine. I mean, I can fully imagine that, especially things like, which always take then a lot of maintenance or working hours, like the control, to get the control work. If you have one system, the controlling works comparably easily because the parameters are connected to each other. If you have a lot of different devices, I can imagine to implement a control system which is really flexible should be a lot time consuming. And then the question is, who can do it anyway?
Yes, we in the Netherlands see now 2 or 3 brands coming up with control systems who are based on artificial intelligence. So they give them a kind of default programming, put the heat pump in the house, and in 2-3 months after installation, the artificial intelligence makes the machine learning, to say it that way. Okay. And then it comes out with its ideal heating angle, operating modus. And the reason behind that Okeda also are very good educated installers, but generally, if they have installed the heat pump properly, let's say adjusting the controls to the house is really a difficult thing for an installer to accomplish. Yes. And if you can skip that by just putting I would say, unprogrammed device in the house, which after that it is starting to operate, the hydraulics, the electricity, everything is connected, the sensors are connected, and the machine does its own work. I think that's already a very important step.
Yes, absolutely.
And that's saving you. If you could do that for each heat pump, that saves you already at each heat pump installation 2 to 4 hours. And that's a lot of time if you multiply that with the annually sold heat pumps. I think we sell now 2 million heat pumps in Europe, according to the numbers of the EHPA.
Yeah.
That saves you, let's say, at least a few million man hours. So, yeah, that's important.
Okay. Yeah, thanks for these ideas.
Yes. And that's what motivated us as a task leader, because we thought that this project is not only of relevance because it's paid work for us, but the moment you start with instead of combining loose components, you're installing a pre-designed, pre-assembled with artificial intelligence provided product. You can just install in the same time more of these devices. And assembling in the factory is always better and faster than at, let's say, the location of the customer.
Yes.
Yeah. Lessons learned. Of course, we have some lessons learned from this Annex. Is that first of all, we learned that you can do a lot by video instead by flying around throughout the world. We normally did for annexes. And I would advocate to still fly around, but do it a little bit less than normally, because via video you can do a very lot. Lessons learned. You need for heat pumps adequate storage, and to shift peaks, you need an appropriate balance of heat pump capacity, storage size, and related components. And the storage size, I don't talk about domestic hot water tanks, because that's a standard thing with the heat pump, but I would say heat pump, storage size, and then what you also want to use for your domestic hot water solution. Second, and that's really Achilles heel of an installer, develop the project as a whole and use the components with the right capacity that can be easily integrated and connected. And so this number 2 really advocates for manufacturing in a factory and not on site. And take the installer out of the equation to choose his components of a CCB type solution. System design should consider all relevant outdoor criteria, especially in cold countries like Canada, where they have fierce winters, for example, but also, for example, Austria. And awareness about heat pump installations and their behavior and performance, as with the final users and installers, still need improvement. Until today, there's still too less understanding about heat pumps. Another thing what we also learned is that if you don't have the CCB in one sheet metal box and you have a good installer, you always can have also a good CCB type of installation with a heat pump, energy storage, and a domestic hot water solution. As long as the control strategy and the controllers are properly adjusted to the installation. And what's also an important lesson is that if heat pumps and energy storage should become and can become a more standardized combination, or if we don't do it, grid operators might force the heat pump industry into it, because the heat pump industry is responsible for becoming more and more a big group of electricity users throughout domestic housing stock in all countries, and grid operators, as we as an industry don't anticipate on it, grid operators might force us into more smart and more integrated solutions. From the heat pump side, overview of lessons learned is that undersized heat pumps increase the thermal energy storage, charging time, and load shifting for peak periods is difficult. So you need a properly sized heat pump capacity. Over the oversizing of the heat pump system and the wrong control strategy is the other way around. You don't need a heat pump which is too big, because then it starts commuting. And this commuting, which is also known as high frequency stop and go operation, is detrimental for the lifetime of the heat pump. And what we saw as a rule of thumb from, for example, Canada, that for each 5 kilowatt of thermal capacity of a heat pump, you need, let's say, a 14 kilowatt hour thermal energy storage. What we also saw in the Netherlands is that we have typical residential applications already with CCB type of solutions with a 4 to 5 kilowatt heat pump and in general 180 liters of thermal energy storage. And until now, a standard in our industry, but we really advocate not to do that way. Backup heaters are not always necessary, and instead of putting them in as a default solution, try to avoid them, because backup heaters are in the eyes of grid operators and a grid load a very, very detrimental thing. And an important thing of the lessons learned is that larger units of energy storage give integrating problems because the space is limited in houses. And of course, it varies a little bit country by country, but generally you can see the square meters floor space available in the houses, which are available in websites from the European Union, are generally a problem for larger storage units. And we also make a real good distinction between thermally stratified water storage and PCM storage, because they both function at a completely different way. The PCMs allows us to have fixed working temperatures, and we could do that on the basis of the heat pump operating conditions, and therefore therewith increase the overall performance of the CCB. A PCM can also help us to reduce the storage size depending on the medium. So what they also can offer is more compactness to the CCB. And storage size and flexibility in the eyes of the Annex 34 team are strictly related. A larger energy storage capacity can offer more flexibility in terms of modification of the electricity demand. And in Canada, they locate the storage components sometimes outside because of the space requirements they cannot meet in the houses. But then you have another problem of the secondary heat transfer fluid cycles you have to protect from freezing. And there you lose a lot of energy again. So as you can see from the lessons learned, there is a lot of things to take in mind the moment you start designing CCB type solutions. And we got some unsolved issues left, but which can also be, let's say, a starting point for the CCB3. What's the road to go? Is a CCB an all-in pre-assembled physical box from a factory? You ship in a crate, you unpack it, place it at the customer, and by artificial intelligence, it does its own work? Or we have this digital smart controller and we use separate components, especially in houses with very tight spaces. To install a CCB type of solution, the separate components under one digital controller might be feasible to do, but one physical box not. So this has also to do with, let's say, the compactness. Another thing we as a group saw is should CCBs like electric cars follow the solutions in the industry and be downwards upgradable during their lifespan. Or we install them with a control set and that's it. We already see now startups, for example, in the Netherlands, with this artificial intelligence provided heat pumps, who say we keep them at the internet and we'll update them with the latest versions of the software. And then how to look into the potential of smart connectivity. How can we make the CCP accessible for smart grid initiatives? Not an important thing to look into, and this was excluded from this annex in the project plan, is cybersecurity. But you can imagine cybersecurity is for a CCP also important, because if you can switch off or on 10 or 20,000 CCBs in one time at a certain geographical area, you can do nasty things with the grid. And there are some people at this globe who have bad plans with us, as you all know. So cybersecurity is an important one. And the last but not least is for mass market acceptance, cost efficiency, surpassing the ultimate energy efficiency of a CCB. And I can spoil already the question a little bit by saying we think cost efficiency is more important than the ultimate energy efficiency, because the energy efficiency we nowadays reach with heat pumps is already very good. So if we lose a little bit of this energy efficiency, but make it therefore together as a package, as CCB, very more cost effective, I think we do a lot of end users really a favor with the cost of the package. And last but not least, we think heat pumps and energy storage have a large potential in peak shaving, flexibility, demand-side response, and lowering annual heating costs because of taking advantage of lower energy costs. We also see we need lower investment costs for heat pumps and installation costs. That's still too high, but the enormous amount for heat pumps at the moment throughout the world are more, let's say, pushing up the price and investment cost than lowering them. That's really a very nasty thing. We see price increases of 10% in heat pumps in the coming 6 months in the country, which is really not fun. We should have more popular storage options off the shelf available. That's important. And although the industry is saying they can, heat pumps have to become smart heat pumps to make smart pumps, heat and storage possible. And we think a grid is as smart as the devices it connects, because the grid is a bunch of cables, but the equipment the grid connects makes a difference. Thank you for your attention. And I'm eager to take your questions, so please feel free.
Many thanks, Peter. This it's just clear to see that this is a lot of information gathered in the last years. Mm-hmm. I'm curious about the final report to have a look into the details. But yes, yeah, very cool. Many thanks. Yeah, I don't know if you have a question, if someone just go ahead or raise your digital hand. Okay, doesn't seem so. Well, then my question was answered, because what I wanted to ask, if you also consider different sensible heat storages, but you just said you also use latent heat storage. So
yes.
Did you also make field tests? Because you said there were some field tests. Have there been some with PCM, or was it more a general view?
No, it was general. There were no field tests specifically aiming for PCMs. No.
Okay. Oh, well,
what I will at 4 o'clock I will have a discussion about CCB3 with the Heat Pump Center from Sweden.
Yes.
And that will be a combination, as far as we are concerned, with ES also. And I think one of the things we should look into more in depth is I think the potential with PCM type of energy storage, because of the space limitations in the houses.
Yes, exactly.
And I think there's a lot to gain with heat pumps in combination with PCM. Yes.
Yes, fully agree. Very interesting. Okay, so if there are no further questions, maybe if you still have some questions. Oh yeah.
Hendrik.
Yes, I'm not sure if it's a question or if it's a Yes.
Well, yes, of course. This was no question, Peter. Many thanks for your nice presentation and your whole work you have done as operating manager, as task manager for this activity. I like it very much, and I feel how deep you are inside this topic, and I can emphasize what you see in the future for this combination. And of course, I have seen that during the expanding of the task activity, we had seen some first ideas what a comfort and climate box can be seen from some first industrial products arising.
Yes.
This was very nice, and it shows to me that we are on the right way for this activity also.
Yes.
Thank you very much for.
You're welcome. Thank you, Henrik.
Okay, so if there's nothing more, I just thank you again, Peter.
You're welcome.
Liked a lot, and I will just share the screen for a spoiler for next time.
Okay.
So here we go. Or not? Yes. So the next energy storage TCP OnSeminar will be July the 21st. Again at 14 o'clock CEST. The topic will be about the energy storage TCP review of 2021. So there is like a final report, which is I guess recently completed, and I'm not sure who will give the talk, but there will be an overview and maybe some milestones and some special ideas of tasks which we haven't heard of yet. Yes, so far to this, and yeah, with this slide we'll close for today. Thanks again for all the participants, and Peter, many thanks.
You're welcome.
And yeah, so have a nice day or evening or wherever you are.